To my channel. In this video, we are going to learn unit number 5, that is software engineering. In this, we are going to learn software project management and DevOps practices. In this, we will learn how to do planning, estimation, configuration, management, and scheduling for modern software delivery. In this project planning, cost estimation, SCM, CI/CD model, CPM, PRT, and Gantt chart we are going to learn. Our roadmap will be project management basic of. In this, we are going to learn goals, the PM triangle, and why projects need managing. Second one is planning and monitoring. In this, we are going to learn turning scope into a schedule and tracking real progress. In third one, we are going to learn cost estimation. In this function point, use case point, and COCOMA, we are going to learn. In fourth one, we are going to learn configuration management. In this, controlling change to code, docs, and baseline. In CI/CD model with GitHub actions, scheduling techniques. These are the topics we are going to learn. So first one is our PM basic, what is software project management. In this, first one is scope, then time, then cost. This is the quality. The application of knowledge, skills, tools, and techniques to plan, execute, and control a software project within budget and to the required quality despite software being intangible and requirements that often change mind flight. Career goals of this project manager are delivering a great functionality to the customer, keep the team productive without burnout, manage risk and cost and schedule proactively. Okay, these should be managed like risk, cost, and schedule proactive. Fourth one is produce a quality product that is maintainable. Now, project planning. In this, the key activities are first we will define scope and objectives, then estimate effort and cost, then identify resources, then build a schedule, then plan for risk and quality. In this planning versus monitoring, we are going to learn how planning and monitoring are different. Planning happens upfront to set the baseline schedule, budget, and scope. Monitoring is a continuous activity that runs throughout execution, comparing actual progress against that baseline so deviations are caught early, not at the deadline. Now, project monitoring and control. What we are going to learn in this first is how progress is tracking. Second is variance type of analysis of that progress. Then milestone reviews of all that progress which we are tracking and analyze. Fourth one is how we can correct action which is not present in that tracking. Key metrics are schedule variance equal to earned value minus planned value. A negative SB means the project is behind schedule and needs corrective action. Now cost estimation, why and how. Before a schedule or budget can be committed, the size of the software must be estimated. Three widely used techniques approach sizing from different angles. Techniques are function point analysis. In this basic of estimation are counts, functional, input or output the system provides to the user. Best used when requirements are known but design is not yet. COCOMA model in this estimate effort and duration from line of code and project mode. Early ballpark, estimated, proposal, stage. All three feed into the same downstream decision, team size, schedule length, and budget. Now, what is FPA? Functional point analysis. This is the formula of FP. In this, UFP into VAF. Like this, you have given here to calculate, where Fi is degree of influence 0 to 5 for each of the 14 general System characteristics. Why team use it? It works for requirements alone. No code needed in this. Language and platform independent and enables productive comparison across projects. Two steps process in this. First we count the 5-step types, data plus transaction and weight. Each is simple, average and complex. Unadjusted function point. Apply a value adjusted factor based on 14 general system characteristics. These are two steps in this. The 5 function point components are ILF, EIF, EI, EO and EQ. ILF is internal logic file, EIF is external interface file, then external input, then external output, then external inquiry. In this, blue one means sky blue is data function type and dark blue is transactional function types. Each is rated simple, average or complex and weighted per standard IFPUG. This is standard tables before summing to UFP. Then use case point. Use case point estimates effort directly from a use case model well suited to object-oriented project when use cases are already the requirements artifact. In this, we will going to learn unadjusted actor weight, then unadjusted use case weight and technical complexity factor and environmental factor. You go through this, what these are. This is the formula of UCP equal to UAW plus UUCW into TCF into EF. Effort equal to UCP into productive factor commonly 20 hours per UCP. Now COCOMA constructive cost model. This is the full form of COCOMA constructive cost model. It is proposed by Barry Boehm. It estimates effort and development time from estimated program size in KLOC. KLOC is 1000 line of code scaled by the nature of the project. In this, effort equal to A into KLOC to the power B person per month. Duration equal to C into effort to the power D months. In this ABCD are constant that depend on the project made. See next slide. Okay. It is used for early proposal stage ballparking before a full FP or UCP count is possible. 3 level of COCOMA is basic, intermediate and detailed. In this, we are going to learn basic is quick early estimate from KLOC alone. Intermediate is adds 15 cost drivers. Detailed is applies cost drivers per phase of the life cycle. Now, COCOMA project mode is organic, semi-detached and embedded. In this, size is less than equal to 50 KLOC. Example is small data processing or inventory system. Semi-detached is range between 50 to 300 KLOC. Example is transaction processing and compilers. Third is embedded. In this, tight hardware, timing and interface constants innovate or unpredicted work. Any size, high constant only. Example is real-time flight or defense system. Now software configuration management. SCM is a discipline of tracking and controlling changes to software, artifacts, code, documents and requirements so that at any point in time the project knows exactly what changed, why and by whom. Typical configuration items are requirements, design and document, source code, modules, test plans and test cases, build and deployment script, user manuals and release notes. Why SCM matters? In this, multiple developers change the same files concurrently. Defect fixes must be tracked back to a specific build. Third one is released version must be reproducible and traceable. मतलब जो released version होता है ना वो रिप्रोड्यूसिबल होता है और ट्रेसेबल भी होता है. रिक्वायरमेंट्स एंड डिजाइन evolve after baseline. Now it is a process of SCM. First one is identification, then version control, then change control, then status accounting, then configuration audit. Now introduction to CI/CD. This is the important one. It can ask in any exam. Continuous integration and continuous delivery automate the path from a code commit to a running tested build, replacing slow, manual, error-prone release with a repeatable pipeline. CI/CD is continuous integration and CD is continuous delivery. This is the process: code, build, then test, release, deploy, then monitor. Automated pipeline is every commit flow left to right without manual hands off. Now GitHub Actions CI/CD in practice. Like this we can practice CI/CD. Pipeline are defined as YAML workflow triggered by repository event. Core building blocks are workflow event, job, steps or action or runner. Now critical path method. What is this? It is a model, a project, as a network of activities and dependencies to find the longest path through the network, the critical path which determines the shortest possible project duration. In this, yellow one is critical path, zero slack, and white one is non-critical, has float. Now we will learn about PERT, Program Evaluation and Review Technique, where CPM assumes activity duration are fixed. PERT accepts that estimates are uncertain and combines three estimates per activity into one expected duration. OMP, optimistic, most likely, and pessimistic. O is for best case duration if everything goes right. M is most likely, means the realistic, most probable duration. P is pessimistic, worst case duration if problem occur. Expected duration are T equal to 0 O plus 4M plus P divided by 6. Now this is Gantt chart visual scheduling. It is lays every task on timeline as a horizontal bar showing start duration, overlap and dependency at a glance, which is why it remains the most widely shared scheduling view. You can see overlapping bars. Now key takeaways. In this, we have learned planning and monitoring, then estimation techniques, configuration management, CI/CD, GitHub, action, and scheduling techniques. These are the topics which we have covered in this unit number 5. So I hope you have enjoyed the video and go through it. It is the main concepts of this unit number 5. Till then, take care and thank you. Have a nice day for this video.